Okay, greetings. Let's talk about, I'm not sure what that was. That was a big loud boom. Angle relationships and triangles. This is lesson 7-2. Today you're going to find the measure of an interior and exterior angle in a triangle by using relationships between these angles, which is pretty cool. So you're going to take a look at your actual triangle. Do triangles today. Not parallel lines, not the other fun stuff. But we deal with exterior angles, interior angles, line segments, remote interior angles, triangle, and vertex. Boom, a lot. So now, a line segment. Highlight this part right here. Super important. A line segment is a part of a line containing two endpoints. Okay, so that means if I'm here to here, one endpoint, everything in between. Now in triangles, I take these segments and form three lines, form a triangle. That's it. Sometimes they could be like this. Sometimes they could be like really teeny tiny triangles. Who knows, right? Essentially, a triangle has a vertex, one, two, three vertex. They're called vertices. And when I take my triangle, I can look at my little angles in here. These are called my interior angles. They all add up to guess what, people? 180 degrees, like magic. When I write it as a triangle, X, Y, Z, examine your zipper. It's called triangle X, Y, Z or triangle Z, X, Y, however you want to do it. But you always want to end it with a segment. Vertices. So X, Y, Z, as you kind of go through it. That's how you name your angles. Okay, can I erase all this mess here? I have no idea. We'll find out. Oh, that's all of it. Erase all of it. Erase everything. Okay. I'm not sure. This is a train wreck. Okay. So if I'm looking at this, okay, if I'm looking at this, if I want to name these things, these guys over by here, right? These guys over by here. This is side YX. Touch the Y first, and then the X at side YX. This is side YZ. This is side XZ. Okay. You could also call it ZY and ZX, but generally want to go, well, to make things uniform, in alphabetical order. Okay. Now, you don't have to, but that's good to do. If I were to name it the vertex, I'm call this by angles, but this is my vertex. This is a vertex here. There's a vertex X. This is a vertex Y. This is a vertex Z. Okay, those are corner vertexes, right? Now, if I name it by angles, this is the angle X. So how I want you to write it, it's going to look like angle X. Not like that. That doesn't look like anything. What you do? Angle like that. X. It's not an X. It's a 7. Doc M, what are you doing? Okay. Um, Angle X. Angle Y. Oh my gosh. A bit of dyslexia kicking in right now. Nope. Erase it. Erase it. Angle Y. Angle Y. Okay, let's make an angle. Angle Y. Good. Angle Z. Okay. That's how you write that. That's the angle. Now, how I prefer you write it would be Y X Y and YZX. When you do the preferred way, I want the middle of the actual vertices to be in the middle of the three letters. That way, no, there's no doubt that's what it happens to be. So that's how you also label and name your angles. Now, one of the things that's really important to know, and this is one of the activities that if we had an online book, we could do this, blah, 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 but, not that big of a deal. I want you to know that when I take all of the angles and add them up, it equals 180 degrees. Boom, it just does. We could do this. We may or may not do it, but you go ahead and take your corners, rip them out, 1, 2, 3, and then lay them like, it makes a straight line. So it all adds up. 110 plus 45 plus 25 equals 180. It's not crazy. It's not alien. It's the truth. The sum of the measure of the angles form a straight line. A straight line is 180 degrees. Add them all up, 180 degrees. That's what it looks like there. So if I take a look at this particular example, whatever this is right here, I can't see this, but I do know this. Then I should find this angle here. Okay, so I'm looking at X, then my right angle. This is going to be 90 here. This is 90 right here. Oh, 90 plus 56. Yeah, plus whatever. So, yeah. So, Doc M is blind. So, I want you to find the value of the X and the flag of St. Kitts and Nevis. I don't know what that flag is about. But Here, this is a 90-degree angle. Here, that's 56 degrees right here. This has to be 90 plus 56. Take that away from 180, and you'll get 34. That's what you know there. I can't read this. I'll get back to you on that one. So here we have angle triangle ABC. Okay, now sometimes there's ratios. We have ratios in with this. So the ratio is 1 to 4 to 5. So if I were to understand that and write it down, it'd be 1 colon 4 colon 5. That's a ratio. Like 1 to 2, that's 50%. 1 is twice as big. So 1 to 2, that means this guy is twice as big as that guy. I have 1 to 4, that means this guy is 4 times as big as that guy. And then the 5 is 5 times as big as that guy. Okay, so when I go back to that, I could actually use algebra to help me find the measure of the angles. So if I knew that I have triangles ABC, and they're all in this particular ratio, 1 to 4 to 5, I could actually use algebra to help me find that. So let's take a look at this particular setup. So we know that the angle measurements add up to 180 degrees. If I let x represent the measure of angle A, which is our first angle that we have, and I know that B is the angle B, the third, because ABC, right? And this is not drawn to scale. I'm just drawing this in there. A is, the first. This might be the 4. This might be the 5. Okay, obviously the triangle doesn't make any sense. No, it's drawn, but it's not to scale. So the measure of angle B is 4 times greater than that. So that'd be 4x. The measure of angle C is 5 times greater than x, so that'd be 5x. So I could use this as my equation. So we have x plus 4x plus 5x equals 180. Now you go ahead and solve it. Combine your like terms. You must combine your like terms first. And so 1x plus 4x and plus 5x, that's going to be 10x. 10x equals 180. X is going to be, guess what? 18. So x is 18. So the first one is 18. Now the second one, should be a dot dot. The second one is going to be 4 times that. So 4 times 18 is at 72. And the next one will be 4 times 18 times 4. 18 times 5 is 90. Now, if I go ahead and take those guys together, if I take 18 plus 72 plus 90, I believe that adds up to, and it should equal, oh, thank God. My calculator, you can too. All right, that equals 180 degrees. So I want you to do the check. Okay, do the check right now. Am I recording? I can't even tell. Oh my God, I hope I'm recording right now. I'm gonna literally cry. Okay, good, I'm recording. Oh, I've had the worst day today. Okay, so do the check. Put that in your ed puzzle. I wonder what is recording. I'll find out. All right, I just had to make sure that I actually was recording the right stuff, and I was. Thank the Lord. Okay, here we go. Now we could do exterior angles, something fun with exterior angles. Now, this is a little bit on the cray-cray side. So take a look at your triangle, and I really think it's helpful to actually use colors with this. Take a look at your triangle, color out your interior, just a little bit thicker. Your interior angles here. These are all your interior angles. Now, if you're to take a line and extend the line, and if you're taking a line, extend that line, you could actually find out the measure of the exterior angles, the angle that's measured right here. So I could find out the measure of angle 6 if I know the measure of angle 2. I could find out the measure of angle 5 if I know the measure of angle 3. I could find out the measure of angle 4 if I know the measure of angle 1, for example. So don't forget that if I take these two angles and I add them together, they should equal what? 180, because it's a straight angle. Look at it this way. This is 4. That's 1. It's a straight line, right? It's a straight angle. So it should fit in there. Now, I got to be able to find out what they are. So let's see what we could do. If I know that these two guys add up to 180, 4 plus 180. I also know that 2 and 6 add up to 180, and 3 and 5 add up to 180. Now, these are considered exterior angles. Now, there's a specific word that's called for some of these, and they're called remote interior angles. So that means this, and this is a little bit crazy. If I take a look at my exterior angle right here, say look at number 5. What is the closest interior angle? That's 3, right? But what is the furthest away? 1, and 2. Those are your remote exterior angles. So I have remote interior angles. They are furthest away from this guy here, number 5, and they're on the inside of the triangle. So 1 and 2 would be considered my remote interiors. So that is what you have to know. If I look at number 6, if I look at 6, it'd be 1 and 3. If I'm looking at 4, it'd be 2 and 3. So if I'm, and they're all a little bit different for this particular drawing. You'll see here, let me erase this guy. Let me erase this guy here. I'm looking at these guys here. If I look at, say, just example number 6, angle 6. Look at number 6. This is an exterior angle. What's his buddy right there? His buddy is 2. Those guys are partners together in crime. That tells you nothing other than that helps identify what your interior is, because that's not the interior, the remote interior. This and this are my remote. This and this is my remote interior for 6. So 1 and 3, because they're away from 6. So if I take a look at that, that helps me figure out mathematically what different angle measures are. So in this case here, if this is my angle measure, I don't know what this one is here. But I'll tell you this, actually I do know, I'll tell you. So 115 degrees is what this guy is right here. If that's 115, that's got to be 65. Now, I don't necessarily know what A and B are. I'm going to assume, let's say, for example, this might be 55. I could figure out what this guy is over here. Like, obviously, if I know 65. But essentially, if I take a look at this, 60 plus 55 is what? 115. So these two guys here add up to this guy here. So these are the remote interior angles. They add up to the exterior angle. Capiche? What does it look like? Again, here's this guy here, A and B. The sum of A and B equals the sum of equals a measure of angle 1. Now, they're saying for this particular angle right here, and I'm going to write it off to the side, this triangle here, 2 is 55 degrees, 3 is 60 degrees. You have to find the measure of angle 1 on the outside. Well, 2 is 55, and 3 is 60. Just add those two bad boys up, right? 115. Now, if this is 115, this has got to be what? So 115 minus 180. I got 65. And 65 plus 55 plus 60? 60 should equal 180. Oh, it does. Yay! Yay! It works like magic. Yay! Got magic going on here. Okay. Erase all of it. I hate Cammy. Okay. Go ahead and do the check. Here's angle 4. You could find out missing angles. So in this case here, angle 4, this is 135 degrees. Find the measure of everything else, essentially. This is 145. Find the measure of the rest of it, of 2 and 1. Okay, don't forget this is 90. That's 90. So go ahead and find that. And then go ahead and do the check. Ooh. Now, we'll do this together in class. That's a fun one.